All right, so hello everybody. My name is Lee Logan, and today I will be presenting my presentation titled Creating a Machine Learning Model for Predicting Streamer Partnership by me. Now, this is my data science project with CS620, and let's go in and get into it. So, this project explores the usefulness of machine learning in the prediction of whether a Twitch streamer will be successful in achieving partnership status. To do this, it leverages two publicly available datasets, one large, known as Twitch features, with 168,000 features, these are each a different channel, and a smaller dataset called Twitch Data Update with the stats of the top 1,000 streamers. To create our overall meta model, I performed data exploration, feature engineering, model development, tuning, and evaluation to identify which streamers are the most likely to achieve partnership. Oh, let me move this real quick to make it more convenient. So again, utilizing these two datasets I mentioned earlier, I created these three models, one on the large dataset, one small, and finally combined them into a meta model. The reason for all of this is I am a gamer and I enjoy watching Twitch streams. I have streamed a little myself here and there. Through this, I've learned that one of the largest struggles for new streamers is learning and understanding what actually matters for growing their channel. Every streamer wants to achieve this important status of partner, and a tool that helps them predict their success, as well as find metrics that lead to the success and help them quantify it, seems like a good idea. So my goal became to develop a statistical analysis, to develop a statistical analysis model with machine learning that would predict a streamer's success in the hopes that they can use it to find meaningful insights that will lead them to a better path. Utilizing the two datasets mentioned earlier, I created these three models. So let's go into some key data insights. The exploratory analysis performed at the start of the project provided me with some key insights into the data. First, looking at this graph, we can see that English is by far the most dominant language across the entire platform. This means that English speakers comprise of the majority of streamers and most likely of viewers. Next, mature content is significantly less present amongst top streamers. That means that those at the top of the top are likely to be streaming for a larger audience of everybody instead of just mature adults. Next, almost all of the top 1,000 channels are partners or affiliate, with maybe 4 that actually aren't partnered. That means once you really make it high, Twitch is going to give you that status either way as long as you have the numbers. Partner status is also highly correlated to view count, watch time, follows, and average viewers. These insights helped focus what our model was going to be predicting in the early stages and previewed some of the challenges of working with unbalanced data in two datasets. Next, go into the model and results. So we had this larger model based on the Twitch features CSV with overall accuracy of 75%, with a balanced precision and recall. And given the size of this data model, which was extremely large, it was a relatively good performance. Now, here's the problem. Our smaller model based on Twitch data.update.csv, it did report an accuracy of 98%, but this was not correct though, as the model predicted partner for every sample. The negative class metrics, aka the zero metrics, were all zero. This means it had no value at all. This revealed an oversight in the model where it struggles to detect this aspect of data, revealing a crucial weakness. Finally, we had our meta model, which is combined from both of the other smaller models, taking the output and using the predictions to make its own prediction. This meta model achieved an overall accuracy of 68%, which all things considered is pretty good. It has balanced performance on negative and positive classes, which is good. And while it is slightly better at identifying the positive class, aka partner or 1, it is slightly less accurate when doing so. On the other hand, for negative classes of 0, it is more reliable and misses a few cases. Here we can see the actual classification reports that were output by the code. One thing I really want to highlight is that problem I said earlier, where our report returned a precision recall F1 score of 0. This is really not going to be very problematic. That's why I went with the path of combining the two models into a meta model, making it so that small minority of negative partnership or negative affiliate was accounted for, making sure that I leveraged the strength of the large model to overcome the weakness of the smaller model. So why this problem matters? While Twitch may not seem important to many people, it is an ever-growing industry that many people make their livings from. Understanding what can drive success can only help, and maybe in the future can even be applied to other avenues. By working through this, we can help new Twitch streamers measure the probability of their success and understand what factors contribute to it, allowing them to focus their efforts in certain areas where they may be lacking, leading them to a better path. We can allow brands, esports orgs, and others to make better decisions by understanding their partners and understanding that if they are to work response to the individual, what are the benefits that that individual may gain and you may gain, allowing both of you to bond, to allow both of you to better succeed. We can support Twitch analysts by providing a tool that can assist them in doing trend forecasting to allow them to better understand the future impact and the future success of their users and streamers. We can provide a foundation for their prediction and other similar statuses. We can provide foundation for the prediction of other similar statuses by providing an interactive dashboard or even methodology/ideas that can be further built upon later. This project demonstrates that machine learning can extract meaningful patterns from Twitch data, even though imbalances and dataset limitations may prevent perfect predictions. Our future direction. While the current project does successfully build a few different machine learning models for predicting streamer success, there still remains many different ways we can go about improving it in the future. First, the model has been negatively impacted by the dataset imbalances, especially when it comes to identifying of users that are likely to be non-partnered. In the future, better ways of sampling/resampling should be used to improve the imbalances in minor class detection. As well, since we have the advantage of having two datasets, we can update future work to focus on refactoring the current method into one that uses hierarchical models and multi-input architecture that leverages both data simultaneously, potentially even as one dataset in one pipeline, instead of the current implementation that treats them both independently and then combines them. Additionally, the integration of other new features, such as time-based features like follower growth, or streaming patterns, could provide strong signals to allow us to predict partnership. Even simple text-based features like biographies or chat metadata could provide deeper industry insights into what makes certain streamers successful. Further integration, not just into features, but also machine learning techniques such as neural networks, could help elevate this project above a simple machine learning project and employing techniques that everyone can use all over Twitch. Finally, one of the biggest and most important improvements I believe could be made is to create an interactive user tool or dashboard where streamers can enter their statistics and immediately receive a predicted partnership probability. If we want to take it a step further, perhaps we could even have the user enter their Twitch name or link their existing Twitch account, and then the software would automatically return the data for them. This could expand the project into not just an idea or this simple tech demo, but a real world tool. Now, let's actually do a demo. Let me go ahead and drag in the Google Colab. So looking here, we can go up to the training models, and once you've run the code that trains the large Twitch features data model, trains the Twitch update model, and trains the meta model, we can then go down to demo and model in use. Once down here, we can see that I've written some code that allows the user to input all of the needed data. Now, while it is a lot of data now, it could be improved further into the future to create a better tool that users can easily access. So first, let's just give 1,500 views. Mature, let's do not mature. Lifetime, let's do 600 days. Dead account, 0. We want to make sure we're using this account. Count days, let's do, again, 600 days. Language, example, EN for English, so we'll do English. Watch time, let's just 3,000. Stream time minutes, just double the number, 6,000. Let's do a peak viewers of 300, average viewers of 50, with 400 followers. Let's say we've gained 400 followers, views gained. Let's just do 3,500. Mature, 0 for the small data set. And language for the small data set, English. We submit. In order to return the probability of you being partnered from the large data set, the affiliate model probability, and the Twitch model probability. Affiliate model is our large model, Twitch model is our smaller model, and meta probability is the combination, aka the real one. So this is saying we have currently about a 30% chance of being partnered. Affiliate model is also around there with 37%. The Twitch model is saying 1 because of its weakness. Ideally in the future, we could leverage this to combine these different aspects such as language and language for the two data sets into one, making one overarching data set that would better be able to leverage the data, eventually foregoing the need to even have a meta model. Well, thank you for listening. This is my short presentation on my data science project. I hope you enjoyed, and I hope to keep working on and improving this project in the future.